Kiran, no screen is visible to you?
Yes, sir. Yes, sir. Visible, sir.
That's very too late. So already we have started our previous class. What is normalization? We have two types of duplicates are there. Duplicacies are there. Row level duplicacy and column level duplicacy is there. And so because of this duplicacy, we have different types of problems. So the problems are insertion anomalies and deletion and updation anomalies are there, right? Next, so if you want to overcome all these anomalies by using a normal form, so the normal forms which can be used to remove the redundancy from the tables, various tables. So we have different types of normal forms. So first normal form and second normal form, third normal form, and BCNF, which is also called as bias code normal form, right? So in first normal form, the table should maintain atomic values, so it should not contain the attribute should not contain multi-valued attributes. That is the principle of first normal form. And so how to convert that first normal form, non-first, not in first normal form into 1NF. So we have to split atomic values, individual rows, even though the table consisting of duplicate values, so you should maintain individual rows, or we have to add extra column for the table by using primary key. That is one principle. Or we have to maintain primary key and foreign key principle. By using that principle, we can decompose the data into 1NF format, right? So that is in 1NF. And closure properties, so we know that we have to find how to find the candidate key. So by using a given relation, we have prime attributes are there, non-prime attributes are there. So those attributes which is having key values, that is prime attributes. Those values which is not having any key, that is called as non-prime attributes. Remember, this is very very important. And the functional dependencies, so we know that what is functional dependency. If the mathematical expression is like that, x tends to y, the y is dependent on x. Here x is a determinant and y is a dependent attribute of x, right? This is about functional dependency. These are the various possibilities of functional dependencies. So next, these are the different types of functional dependency properties. So we have to read all these things, right? There may be chance to ask in final exam, uh, uh, write about various functional dependencies properties. If you remember all these things, then only you can write all these things: reflexivity, augmentation, transitivity, union, decomposition, and pseudo transitivity and composition, right? So next, the very very important is that now we need to discuss about second normal form. Here, if you observe, the rules of the second normal form is that, so the second normal form is that, so the table or a relation must be in first normal form, right? And the second one is that all the non-prime attributes, you know that what is non-prime attribute. The non-prime attribute means those attributes which is not having any key values, that attributes are called as non-prime attributes, should be fully functionally depend on candidate key. This is another rule. And the next one is there should not be, there should be, which means that there is no functional dependency, which means that there should be no partial functional dependency in relation. This is another. So let us consider this is the customer table. It has some attributes: customer ID, store ID, and a location. It has their own values. So how many attributes? How many three attributes are there? How many How many rows are there? Five rows are there, right? Five rows are there. If you observe here, so if you observe here, here this customer ID is duplicate values are there, and here also store ID is duplicacy is there, and delete all these are some different types of duplicacy is there. Now we need to find what are the different types of functional dependencies existing in this customer table. So now I need to split this table into two more table. So so before splitting, decomposing these two tables, we have to find what are the what are the candidate keys. The customer id, store id, these are all not a these are all not a at present these are all these are all not a can keys. If you add if we add these two, 1 1 1 3 2 1 3 2 4 3. So if you add these to customer id and store id, we can get a unique 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 row. So that we have to composite candidate key is that customer id and store id, right? So if you see here, location, the location is another attribute. I am considering this one as a non-prime attribute. So according to prime and non-prime attribute, here we are making these two as a composite candidate keys, because these two are if you combine these two, we can get a unique unique rows, right? So candidate key is a customer ID and store ID. Here the prime attributes are key attributes, so that customer ID and store ID is a prime attributes. The non-prime attributes are location, right? Location. So we have to split this table into two more tables. So the first table is customer id and store id, customer id and store id. We have to maintain these two composite keys into a single table, so that we have to replace all these five rows in one table. Next here, if you observe here, the if you store id and location, here one delhi and three mumbai and one delhi and two bangalore and uh, three mumbai. If you take a store id as a primary key, if you make this one is primary key, so we can get distinct values, right? So one delhi, two bangalore, three mumbai, right? So according to this no, second normal form, all nine non-prime attributes should depend on fully functionally depend on the candidate key, and there should not be maintain any partial functional dependencies. So one more rule is that, so if the table consisting of both attributes are non-prime both attributes are prime attributes, so prime attributes, which means that it has if the table has a prime attribute, so that this is called as this is in second normal form. Or if the table consisting of one attribute is non-prime attribute and second attribute is prime attributes, the non-prime attribute depend on the prime attribute, this is also second normal form. So if you observe here, this is also second normal form. So finally the table is in. So if you decompose the entire table into two more tables without any problems, so then we can say that these tables are in second normal form. Remember, all non-key columns are depend on fully functional depend on primary key, right? So next and there is no partial functional dependency. Now we have to see what is a partial functional dependency, right? So right, partial functional dependency here, if you observe here, the location is, if you make these two are customer id and store id is keys, the location id is the location id is depend on part of the store id, it is not depend on customer id, right? Next third normal form. So we have a third normal form. The third normal form is that the table or relation must be in second normal form, right? So which means that second normal form means there is no partial functional dependency. And the second point is that there should be no transitivity dependency in the table. For suppose the transitivity dependency means, you know that a tends to b, b tends to c, then A tends to C. This should not be happened inside the 3NF, right? Inside the 3NF, so that if the table consisting of transitive dependency, you have to remove and convert into 3NF, right? So that is one principle of 3NF, third normal form. So consider third normal form, right? So next, BCNF. BCNF means Boy's code normal form. According to Boy's code normal form, so here this is the table consisting of different types of attributes are there, different types of values are there. We have one, two, three, four attributes are there, right? Four rows are there. Now according to Bayes code normal form, so the candidate keys are roll number and roll number is there, and water id is there, right? These two are candidate keys. According to Bayes code normal form, the left side of the functional dependency should be candidate key, right? Roll number tends to name, roll number tends to water id, and water id tends to yes, water id tends to yes, roll number. All these are left. If you consider left side, if you concentrate on left side part of this functional dependency, so here roll number is, what is that? Roll number is okay, a part of the candidate key, roll number, and so here water id tends to age. This is also water id is a one of the what is that key, and water id roll number, both sides these two are keys. Even though these two are keys, this table is in Bayes code a normal form. So according to this Bayes code normal form, finally we have to understand, so we have to find what are the candidate keys from the table. We have to write that candidate keys table. Along with that candidate key, we have to form what are the different types of functional dependencies are available inside that table. That is Bayes code normal form, right? So here, Bayes code normal form, right? So, and the next topic is that, just wait. Okay, the empty screen is visible to you, Kiran? Kiran, hello?
Yes, sir. Visible, sir.
Yeah, now we have to discuss one more important topic, which is related to this functional dependent. What is that? Normalization. Here, the topic is that we have one more normalization technique. The normalization technique is lossless, loss, lossless decomposition, or lossy decomposition is there. Lossy decomposition is there. This is very, very important for your final exams. Lossless and lossy decomposition. For suppose if the table consisting of redundant values, we have to decompose that values and apply some normalization techniques, and we have to remove the redundancy, making that required normal forms, right? So here, lossless decomposition, lossy decomposition is one of the normalization technique, which is also called as fifth normal form. Fifth normal form. For suppose if you take one table, The table is like this. Attributes are A, B, C attributes are there. So it has some values. Values are 1 to 1 and 2 to 2, 3, 3, 2. These are the values of values of the table. Some table name is ABC table. ABC table. Now I need to decompose this table into two more tables. So two more tables, how to divide? While 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 decomposing this table into two more tables, the table two tables should be in a common column. Common column, right? So here, if you observe here, so we have to find the values. Select for suppose so we have to find two tables. First R1 table is there, R2 table is there. In R1 table, I need to split how to R1 table. So we have to maintain AB, and the second table is BC. The second table is BC. I need to split like this. So AB and BC. So here, according to this decomposition technique, we have to maintain the common column in R1 and R2 both tables. So how many tables? If you divide three more tables, so you have to maintain all three more tables in a common column. So make it like that. So this is first table. This is second table. In first table, how many R1 table? How many attributes are there? A, B. And second table R2, how many attributes are there? B, C. Here, which one is common? Which one is common? B is common, right? So AB, how many? AB, 1, 2, 2, 2, 3, 3. BC, 2, 1, 2, 2, 3, 2, right? So once you split these two, now I need to write a query. So we have to find find the values from r2 dot c values, r2 dot c values from r2 table. Natural join r1 by using where r1 dot a equal to 1. Like that, if you want to answer this type of questions, so r2 dot c from r2 table and natural join r1 where r1 dot a equal to 1. If you want to answer this type of questions, this answer is not available in a single table. This is available in both tables, so that we have to apply the natural join and combine the tables. Once you applying the joins, from that only we have to retrieve this query answer, right? So here natural join means we have to apply the cross product and cross product plus apply the cross product and plus apply the condition right? So once you apply the cross product condition here, uh, the three rows are there. Here three rows are there. 3 into 3, 9, 9 rows are available, right? So here, if you observe here, we have a common attributes columns are there. So what are the common attribute columns? We have table A, B, and B, C. This is belongs to R1. This is belongs to R2, and the first row is 1, 2, 1, 2, 1, 2 is product with second table 2 1 and 1 2 2 2 and 1 2 and 3 2. First row is over. Next, in the similarly we have to find 2 2 2 1 and 2 2 2 2 and second 2 2 3 2, right? Second row also over. Next one 3 3, find 3 3, 3 3 with what is first one 2 1 2 1 and 3 3 with 2 2 3 3 with 3 2, right? So this is a table for this applying after natural, what is that, natural join. Now we have to retrieve the data from the condition, right? This is the table. So if you want to extract the data from this original table after applying natural join. So if you observe here, this is common, this is common one, this is common, this is common in both tables, and 3 3 this is common. Finally we have to select all these. So the original table consisting of after applying the condition a b c, this is table, and 1 the common value is 2 and 1, and 1 the common value is 2 2 and 2, and next what is that, 2 2 2 1 2 2 2 and 3 3 2. This is the original table. So how many rows are there? 1 2 1 and 1. So this is one table. There is a resultant table. If you compare this resultant table with the original table, in original table how many rows are there? 1 2 3 rows are there. So here, how many rows are there? 5 rows are there. If you compare these two, the resultant output consisting of two more rows are extra, right? So what are the two more rows are extra? And 1 to 1 is there, 2 to 2 is there, and 3 to 3 is there. So 1 double 2. So if you see here, these two are extra rows, extra rows. So which is called as, this extra rows is called as, in dbms we have separate terminology is there. So that is called as spurious tuple, which is called as spurious tuples or extra rows, right? According to dbms terminology we have to write spurious tuple. So because of if the table consisting of the resultant table consisting of extra rows, or and the table consisting of uh, uh, less values compared to original table, which is called as this table is called as a lossy decomposition. Lossy decomposition, lossy decomposition values, right? Lossy decomposition, right? So if you want to remove this lossy decomposition techniques, now this is lossy decomposition techniques. So because while we are selecting the tables from the starting position, if you observe here, while we are decomposing the table here, r1 ab, r2 bc. So while decomposing these two, so we have to concentrate on common column. Here the common column should not be should not be redundant values, should not be redundant values. If you observe here b22, this is the redundant values. We are taking these two tables inside these two tables as a common column, so that we can get this type of lossy decomposition. So while splitting this table into a decomposed table, the common column should have what is a composite common column should have a candidate key. Common column should have candidate key. So here this is not a candidate key 223, this is not a candidate key C122, this is not a candidate key. If you observe here, this is candidate key, this is candidate key, it has some unique values 123 is there. So that while splitting this table into a decomposed table, so R1 of AB and R2 of AC, right? R1 of AB and R2 of AC. So apply these two. So then we can get a lossless decomposition technique. Apply so once you split these two, and again apply the same procedure and apply the condition, and we can get a so lossless decomposition technique, right? So here so uh, the condition is R1 union R2 equal to this is the one table R1 union R2 equal to capital R. So if you observe uh, AB union AC, so we have to maintain ABC. This is original table. Even though we are applying union values, apply ABC. These two are common, so that A and remaining values are A. Remaining values are BC, so that ABC. Right. So here R1 intersection R2 should not equal to 5, right? So here if you observe here AB intersection AC, so here the common value is A, it satisfies this condition, it is not equal to 5. This is also should satisfy while converting into the lossless decomposition, right? If you get if the values are common in both tables AB and AC, first table and second table, the table should consisting of the table should consisting a common column. The column should be in candidate key position, candidate key position. This is about decomposition of this table, right? Right, remember the common attribute should be here here we are taking R1 of AB and R2 of AC. The common column should be candidate key or super key of either in R1 or R2 or both tables. Then only we can get a lossless decomposition data, right? So this is about lossless or lossy decomposition technique. This is one type of fifth normal form. So in your final exams, there may be chance to ask what is lossless and lossy decomposition. If they are asking lossy decomposition, we have to explain all these things. What I told. If they are asking lossless decomposition, we have to split with the key position. We split with the key attribute, then apply all these techniques, all this total procedure, then we can get lossless decomposition. This is about one, or there may be chance to ask in what we explain fifth normal form. Both are same for both questions, same answer, right? Fifth normal form and so this is the one of the technique to normalize the data from redundant data into distinct data, right? So this is about normalization techniques, and the next we have one more topic is there, that is called as a dependency preserving. So that is also one of the normalization technique to remove the redundancy from the table, right? So I'll stop today class. I'll continue, and we have day after tomorrow we have class. I'll teach what is decomposition techniques, what is the dependency preserving, what are the different problems in dependency preserving techniques. Then we can understand easily, right? Okay, all of you, hello.
Yes, sir.
Yes, sir.
54 members are attended. What about queries? Tomorrow is the last day. Tomorrow, 10 o'clock, you have to submit. Okay.
Yes, sir.
Chandrasekhar,
Yes, sir.
what about our DBMS 1 week lab plan? All are coming or what?
Yes, sir. Maximum వస్తారు అనుకుంటున్నాను.
Okay, okay. Okay, I'll stop the class. Same class on Thursday. On Thursday, we don't have class on tomorrow. Maybe day after tomorrow, Friday. Okay.
Okay, sir.
Okay. Thank you all. Thank you. Thank you. Okay.